So here comes the precise or the delta epsilon definition. We're going to say the following. Let f of x be a function defined on some open interval. Okay, that contain x equals a the open interval contain x equals a except, and this sounds like a little contradiction here, but except possibly at x equals a exactly. So the x equal a may be or may not, but x equal a is within some open interval. Now x equal a may except possibly, so we kind of allow for x equal a to be a whole, okay? And so in this case, we're going to say that then the limit of f of x as x approaches a equals L if for every number epsilon positive epsilon in this case, there is a number delta positive number delta such that if x minus a, the absolute value of x minus a is less than delta, but is positive, then the absolute value of f of x minus L is less than epsilon, like so. Okay, and this concludes the definition. So, what do we take on this? We have some open interval that with a value of x equals a that may or may not be on the interval because that may be a whole, but we're going to say that the limit of f of x exists and it's equal L if for every number of epsilon. In other words, we can come as close to L as we want to be. Epsilon can be as small as we choose to. It doesn't matter how small it is, we can always find a delta, the tolerance on the input x, such that if x minus a is less than that value of delta, then f of x minus L is less than that or tolerance on the output. So epsilon is the tolerance on the output on the y value, delta is the tolerance on the input or the x value. Okay. A little interpretation here, and this is a repetition of what I just said, but let's write it. We're going to say that the limit, so this is the conclusion of the definition right here, so let's draw a little line here, and the interpretation, we're going to say that the limit as x approaches a of f of x equal L means that for every epsilon positive epsilon, and in parentheses, no matter how small, we can find delta, positive delta, such that for this particular delta, instead of writing it like so, this can be broken. Remember how we started it? We can say that x can be either greater than a minus delta or less than a plus delta. Remember, this is a was 3, so we said x can be a value between 3 minus delta and 3 plus delta. This is the tolerance of the input. So if this happens, then the output will be f of x can be either greater than L minus epsilon or 5 minus 0.1 in the example, or less than L plus epsilon or 5 plus 0.1. Okay? So this is the interpretation.